Access College is owned by the government or is a private
Yes and no.
business?
It's owned by like the state government.
Yeah. Sorry. I'm gonna celebrate anybody
So the parents are the government, like,
kind of waiting to see if anybody else comes. Let's see.
And then each state has its own government.
What's that?
So if you work for the federal government, you're not getting paid
or
right now.
just
Because they can't.
Oh, you're just saying that? I think
That's
that's Kendall. Let's see.
They mean probably overslept in the morning.
If you work for the
That is
state
Kendall.
government, you're still getting paid.
Kendall!
back in the
2, 4, 6, 7. Then there were 7. We're only down 6, so we got over the. No, wait. We're only down.
The state government,
Yeah,
not
6.
the federal government.
Wilson, Danica, Corinne, Fatima, Damien. Yeah, Jeez. Okay. We just got over the 50% mark in terms of people showing. Let me see, what do I have here? Braden and
Oh no.
oh, dare I look at your stuff? Aubrey, finally, she's a Lord dude. Sierra. All right. Well, let's see if anybody else stumbles in. For everyone who just got here, I've already said this multiple times, so I'm not going to go back on it, but I'm going to give us tomorrow night off. The fact that there are a lot of people missing tonight made that kind of funny as I made that decision earlier. Yes?
Sorry, nope, I just have a question.
Yeah, go for it.
Well, so when you get a negative remainder in synthetic division, so if I was dividing by x minus 1 and my remainder was negative 1, that would make it negative 1 over x minus 1.
Yeah.
Which would make it plus 1 over, no, y.
Well, it would make it plus 1 over 1 minus x. You'd have to change all the signs. That's why you change the sign.
Yes, that is.
Oh, okay. I was like, why did you?
Why would you do that?
Because you made the next one, you did that correctly. I'm like, why did she do the wrong thing? It's because you changed the
I
sign.
did half the-
Does that make sense?
Yes.
Yeah, okay.
Okay.
All right, so let's do this. I have a little outline of stuff I want to get through. But let's remember what we've done so far, most recently. Can somebody tell me succinctly what a log is?
The inverse of an exponent.
Kick ass. What's a more practical computational way to look at a log? Somebody else. So, So like f of x equals log of 7 base x. Log base 7 of x is the inverse of 7 to the x. Yes? And really quickly, why is it important to know a function and its inverse? Why do you think that's important to know, Kendall?
Because then you can graph it.
No, you can graph the function fine on its own, right? If you want to solve the equation cube root of x equals 3, do you have to know the inverse function of cube root? Of course you do, because how do you solve cube root of x equals 3? How do you solve that?
You raise it to the third power
Yes, and why do you do that?
because it kills each other.
Because cube root in cubing is the opposite. Yes? So I can make it as silly as x plus 7 equals 9. We have to know what subtraction is to be able to solve that, right? So anytime you're going to learn we're going to learn several new functions still later this semester. Every time we learn a new function, we're going to have to learn its inverse. If we don't, we can't handle it if they show up in an equation. Okay, I like it. Kick ass. In the real world, functions show up in equations so that they can model observations we make. So it's not like in class, I choose what function to put into an equation. In the real world, a function just shows up because it best models the situation. You have to know how to handle it. You guys kind of, okay. So remind me how to do a problem like, what do you got, Jeff? Let's do this one. What's log base 8 of 2? What is that asking you? Let's start there.
It's asking what power does 8 need to be raised to?
Yes, what power do I need to raise 8 to? to get 2. Now, 8 to the first power is what?
8.
So obviously the answer is less than 1, because the power of 1 makes it 8. It's got to make it 2, yes? So it's got to have a power less than 1. What's log base 8 of 1?
It's like 2.2 something.
0.
0. So it's got to be between 1 and 0, because that one have a 2, right? So it's got to be some kind of a fraction. And of course, fractional powers do what? 1/2, 1/3, 1/4.
Square,
They become roots. Yes?
Okay.
Alright, so if I have a base and the inside number is smaller than the base, but bigger than 1, it's got to be some kind of a root. What you got?
it's not better.
Yes, so I have to take the cube root of 8 to make it 2, yeah? So here's something kind of cool. I want to point this out. I need you to understand that by itself, and then I'm going to show you a nifty little method. What's log base 2 of 8?
3.
This is inverted, so I just invert the answer. Yes? If log base 2 of 8 is 3, log base 8 of 2 is 1/3. It takes 3 of these to make this, so it takes 1/3 of these to make this, because they just kind of undo each other, yes?
Can you explain real quick why fractional exponents do that?
Yeah, sure.
Just
Talk about it.
like half speed.
Hello. Sorry.
Half speed. Half your regular speed.
Oh, I'm sorry. Let me pretend like misheard you.
I feel like that's an eighth of your normal speed.
I know. That's why I said let me mishear you. Okay. I like to play myself on YouTube going like 0.25 speed. And I sound drunk. It's great. You sound drunk. Shut up. So, square root of 25. Let me explain it to you in a less than satisfactory way. And then I'll explain it to you in a mathematical way, which I don't know if it'll be satisfying. Square root of 25 literally asks you to cut 25 in half, multiplicative, right? Exponents are based on multiplication, yes? So if I have a 2 in the exponent that says take 2 of these and multiply them. If I have a 1/2 in the exponent that says take 1/2 of these multiplicatively.
So those are the same thing.
Yes.
Okay.
And let me show you even better. So that's the kind of like hand wavy way. You with me?
Okay.
Okay. What is 25?
What is it?
Yes, as in terms of this problem. Like what is it raised to the what power? 25. What number do I raise to what power to make 25? 5. Okay.
Yeah.
Do you see how
Those,
this would cut the power in half?
because when you raise something with a power to another power, the power.
You multiply the powers.
Multiply them?
Yes.
Okay.
So this would be 5 to the first, which is what square root of 25 is,
Okay.
right? Now I want to point out, you guys don't even realize this, but the reason roots don't make the most sense to you is because they shouldn't frickin' exist. This is all we really need. We made that shit up on top of this. Because we thought, oh, that'll be easier to look at. No, it actually doesn't jibe with the other stuff. It doesn't look like a power, and it is a power. So if we just didn't teach root notation in the first place, we'd all be 1/3. Power means cut it in thirds multiplicatively, which is what a cube root asks, yes? Cube root is something, cut it in thirds multiplicatively. 1/3 in the power, cut it in thirds multiplicatively. Why? Because powers are multiplication. Yes? Okay, maybe. I don't know if any of that was good enough.
So it's, but you're not multiplying the base number by 1/3 then.
No, hell no. You're not. That's not what you're doing with any power, right? There it is. Wow. Oh my God, there's stuff here. 4 to the 5th power. Am I multiplying 4 by 5?
No.
No. In fact, here's this kind of.
No, I won't.
You ready? You ready? You ready? You ready? You ready? Okay. This is 4 times 4 times 4 times 4 times 4, right?
Oh, no.
Alright.
I'm sorry, it's 4 plus
Ba 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 ba. 4 to the first is 4. let me see if you guys are cool with this. 1/2 of 6. What is 1/2 of 6?
3.
Because it takes 2 3s to make 6. Right? Additively. Alright, so maybe this would work. And I've taught this way before too, now that I think about it. Coefficients deal with addition. Are you cool with that idea? People sometimes balk because they say 7x means 7 times x, but what does that actually mean? It means 7x is adding, correct? Multiplication, this is repeated addition. Are you guys with me?
Yeah.
Coefficients mean addition. So when I put a 1/2 as a coefficient, that should sort of freak people out. Like if I say 2 6s, put a 6, 12. If I say 1/2 6, that should freak you out as much. What the shit do you mean? But 1/2 of 6 means what number does it take 2 of to make 6? Yes? Additively. So is that cool all by itself?
Yeah.
So the trouble you're having with 1/2 of the power is the exact trouble you should have with this, but we're more used to this kind of thing. We've seen it a lot more, right? So this means what number added to itself is 6. Yes? This means what number multiplied by itself makes 9. For the exact same reason. Yes?
Okay.
9 to the first is the whole 9. 9 to the 1/2 is cut 9 in half and take one of them. How do I cut 9 in half? Multiplicatively, because it's in the power. If I said 1/2 of 9, like it was a coefficient, I would cut 9 in half additively. And then I would get 4.5.
Okay. That's tracking.
It's a really good question. To be honest, I haven't taught like this, you know what I mean, for a while, so I'm like remembering all the ways I used to show this.
Yeah. Nobody ever explained to me like how exponents why they work. I just had to like.
And really quickly, that's exactly what this kind of course is built for, right? And we do that in pre-calc, for example, if somebody asks, but in pre-calc there's so many topics, I don't have time to live with it for a while. This course, this is exactly where you ask anything that's been troubling you, right? That's my job. My job is to figure out how to explain it. Okay. Did that help? Yes?
So if we have like 9 to the half power, we just multiply half by 9?
No. Okay. 1/2 of 9 means what number do I add to itself to get 9?
Yes.
What number does it take 2 of to make 9?
4.
Yeah, 4.5.
Yeah.
9 to the 1/2 power means the same way coefficients mean addition. So that's why this question says, what does it take 2 of to add to be 9? Exponents mean multiplication. What number does it take 2 of to multiply to be 9? 3. And this does the job that this wants us to do. That's why they're equal to each other. Okay, kick ass.
That does make more sense.
I like it. And then, of course, that leads to the shortcut about put the root on the bottom and the power on the top and blah, blah, blah. Those are just ways to remember how to rewrite them between the 2 different versions. But I like the idea it's better to get to the concept. Why does it mean what it means? I love that shit. Okay. Yep. Let's see. So, can somebody remind me what this would look like? Very, very rough sketch. What would it look like? Can you guys draw it in the air? And let me be very specific. A greater than 1. Yeah, I love it. Kick ass. Ooh. Zip. To the moon. Yes. Okay. It's very important, and I wear that shirt every now and again with the little dancing people. Yes. The more you know the shape of basic functions, the easier so much shit will be. So, you know the shape of it. What is happening at the beginning when you go to draw it? What is this behavior? What is this behavior back here? Asymptotic, right? There's an asymptote there. So if you remember the shape of it, you might remember, oh, there's an asymptote there. That's why it's doing this thing. Yes? Okay. So for this, there's an asymptote at 0, goes, this is 1, this is A, and this is 1 over A. Yes? So we looked at 2 to the x, we looked at 3 to the x before, yes? They all have the same shape. Then I can move this shit around. We talked about that a little bit, yes? I can move this stuff around. You guys picked up on that real quick. Kick ass. Can someone remind me what the shape of this was going to be? Yeah, do it again. Yes. So it's got to be the reflection of that guy, right? So that guy is this. The other guy has to be, from your perspective, this. So what's going on here?
It's a vertical asymptote.
Vertical asymptote. And it makes sense. If you think about it, when I invert stuff, x becomes y, y becomes x. So if I have an original asymptote at x-axis, now the asymptote is on the y-axis. Does that make sense? When I do the inverse, all the x shit flips with the y shit. Literally everything. So what does this mean about the domain of log? It's log, it's log. Where's there an asymptote? Yeah, y equals 0. I'm sorry, x equals 0. So, what inputs can I not use? Can't use negatives. There's another input I can't use. 0.
So everything less than 0.
Yeah, less than or equal to 0. So the input has to be greater than 0. Are you guys with me? I love it. So do you remember problems where I would say, actually you'll have to help me remember, but good. Find the domain of this. Have we done that? Okay, thank God. Sorry, there are a lot of the concepts we do in this class overlap with other classes, so I'm like, what class is it? So remember, what did I do here? I said the inside has to be at least 0 in English, and then I do it in Mathish, and then I solve for x, yes? With me? So guess what we're going to do now? We're going to give you natural log of 4 plus 5x, and we say find the domain.
Ooh, a new letter symbol. Natural log.
Oh, didn't I do that? No, I haven't done that yet. Sorry. Sorry. Log base 7. There.
Spoilers.
Oh, man. Don't look behind the curtain. That's right. This class, we don't know what the shit that means yet. Okay. So, remind me, every log, what's got to be true about the inside?
No. That's asking.
What did we just say up here? What's the domain for a log? Pass here. So in this case, if it's just this, x has to be greater than 0. So in general, what must be true about the inside of a log? Got to be greater than 0. So I need you to understand. To stay real, what's inside the square root has to be greater than or equal to 0. Because if I put a negative in there, it becomes complex, yes? And we don't want to let that happen if we don't have to. Right? Trippy things happen, you get all colorful, hands come out of nowhere and those things. Okay. You never, you still listen. Right. Logarithms, I can't allow the inside to be 0 or below because weird shit happens there. Very quick side note. If you're curious if complex numbers come in when the inside is 0 or negative, yes they do. Are we going to look at it? No. Even if you want to. We could. So for this problem, what I'm going to do, the inside has to be greater than 0 because there's an asymptote. I'm not allowed to even be 0. So 4 plus 5x has to be greater than 0, and then I solve it. Yes? Okay. Yes?
I know that there are special rules for solving inequalities. What are they?
The only rule, well, okay, let me say it this way. When I'm solving linear inequalities, the only rule that's different is when you divide or multiply by negative, the sign flips.
Divide or multiply by negative.
Yes.
Okay.
Do you guys know why? Have I shown you why? You guys remember that first off?
I do, but I don't know why.
So for example, if I want to solve this, it's almost solved, right? I have to divide by -1, and you have to flip the sign. Yes? Do you guys remember doing that?
Vaguely.
Vaguely.
Ish.
Watch this, you ready? This is my favorite answer in the world because the answer is cuz. Which one of these is bigger?
2.
That's crazy. If I divide both sides by -1, which one is bigger now?
1.
What happens? Yeah, so when I multiply or divide by -1, don't I change what side of 0 I'm on? So whatever was bigger or smaller, whatever was smaller is bigger now. It's just called it's called a non-order preserving operation. When you multiply or divide both sides of an inequality, you change the signs, you change the side of 0 it's on. So 4 is bigger than 1. If you multiply by -1 is bigger than -4. You changed. So even if it's a freaking number that I don't know, it's just a number. What students don't realize, and I don't blame you, is variables are just numbers. They're numbers we don't know yet, but they have to act like any other freaking number. So if I do it here, I gotta do it here. Why? 'Cause it's what happens. It's how numbers work. You with me?
Yes.
I could say something really stupid like this. Same thing happens when we divide with an equation, but when you move the equation, then it just looks the same, but it's still crazy. All right. When you flip the equation symbol, it's the same. Ooh, okay. You with me? So it happens all the time. I appreciate it. Ooh, it looks like bars. Okay, sorry. All right. I appreciate that. Okay. What was I talking about? Oh, all right. I'm not gonna. I can't remember how much of this I assigned in the homework, but let's do one example of this at least. I think if I needed to graph this. I need to graph that. You could do this 2 different ways. First off, let's do this. How do I figure out the domain?
Inside has to be greater than 0.
Inside greater than 0. So x greater than -3, right? Already, without knowing, I know the graph is going to start right next to -3 and go up. Yes?
I thought we only flip the side. Oh, never mind. I have that one.
I like it. You only flip the sign when you multiply or divide by negative. Don't flip the sign because there's a negative in there somewhere. Right? Okay. Another way to look at what's going to happen is how will this transform? How will this move? What would this do? Left 3, okay. So we have both, look at how this is working together. Normally, where's my asymptote? At x equals 0, yes? If I move everything left 3, where should my asymptote be now? -3, so then my whole graph has to be above -3, or to the right of -3, you with me? So this matches up with this, thank the gods. Now, you always want to graph the base function. You have 3 anchor points. So I'm going to graph this, I'm going to make it dotted, because it's the base function, and then we'll graph the transformation. Okay. So what's log base 2 of 1? What's log almost any base of 1? What do I raise anything to get 1? 0. So every log, if it hasn't been shifted, is going to go through that point. Does that make sense? Log base 2 of 1, what power do you raise 2 to make it 1? 0 power. So it's going to go through the point 1, 0. What's log base 2 of 2? What do you raise 2 to make it 2? To the first power. And what's log base 2 of you can do it, Jeff, 1/2. What do I raise 2 to make it 1/2? -1 to make it flip, yes. So 1/2 would be -1. Those are my 3 anchor points. they mimic the anchor points I had for the exponential in the first place. So this is my base graph. By the way, just a quick side note. Logarithms are some of the slowest growing things. They grow so stupid slow. If you make it to Calc 2, and I'm teaching you, there's some cool shit that happens because log grows so slowly. So it's a good thing to know. So how did we just say everything should move? How's everything move? Sorry. Left 3. So 1, 2, 3. 1, 2, 3. 1. No, Jeff. 1, 2, 3. And then the asymptote moves 1, 2, 3. So now it's here. Does it match up with the domain that we figured out? Does it match up with the domain we figured out? Yes. It's only using inputs above or to the right of -3. Greater than -3. Okay. How you guys feeling? I sense not well. Yes.
Well, if you try to put -3 in for, it would be 0 and then it would break.
Yeah. If the inside of a log goes to 0, that is where the asymptote is. Because it's not allowed to be there. Yeah. Okay. It's allowed to get closer there, which is where the asymptotic behavior comes in. Yeah.
What makes it go like the inverse to go with both of them this way versus like one this way and one like the opposite?
Oh, because the only transformation we made was move it back 3.
Oh, you're right.
It has to have the exact same shape, just starting back there. If I had a negative out front, that would have like flipped it this way, so then it would look like this, yes? Is that cool? Yeah. If I put a negative inside, that would flip it around this way, so then it would look like that. So all the same stuff we did before, reflections, transformations, compressions, all that kind of crap, yes? I really hope I don't want to do too much of this, because just knowing the basic look of a log helps a ton, okay? Trying to get to a point where I can give you this little sheet here to work on. Oh, perfect. I'm almost there. You guys know pi. You ever heard of pi? You know pi, right? I was waiting for that. And then here's the next question I would ask. Where does pi come from? There it is. Okay. Where does the mathematical pi come from? Circle. What about a circle? You guys know where pi comes from?
You explained it to it very good. It's like the ratio of the.
Yeah, so this freaked civilization's out. This freaked entire civilization's out. No matter how small or how big your circle is, if you take the radius and you take the circumference, when you divide the diameter, you take the circumference divided by the diameter, you always get the same number. Can you imagine being an ancient civilization, not much going on? You got your candles that you just invented, you got papyrus that you just invented, you have nothing else. You're like, what are you going to do? Oh, let's play with circles. Okay. And then you realize, wait a minute, dude. If I take how long the circumference is divided by, I don't care how big the circle is, I get the same dumb number, yes? Now, they were just humans. They didn't have frickin' TI calculators, yes? They didn't even have the TI-1. Wow. They didn't? No.
How did they do
They had the TI tablet. Chisel the stuff in.
Uniform edition.
Yes, exactly. What was I trying to say? Yeah. So they came up with approximations. The Egyptians came up with 22 sevens. Other civilizations had other ones. That's the only one that I can remember off the top of my head. What's 22 divided by 7? No. They wish.
3.14285.
Yeah. So for freaking ancient Egyptians, that's some good shit. Yes, that's pretty good. All right, I need you. So we eventually, they thought it was from God. Of course. I mean, all the weirdest, freakiest shit comes from God. So we're like, this must be weird, freaky shit. So let's call it. So what they did was they gave it a symbol. Now their symbol was different, but we eventually called it pi. Yes, so it's the same idea, just a different letter. We use the Greek one because whenever you want to make things look nifty, they use Greek. So like Super Bowl, right? Super Bowl 38. Roman letters. Roman numerals.
Drawing out a little Egyptian hieroglyph every time
I
you do
know.
this.
That would have been better. And then that's where pi comes from. Okay, you guys with? And then of course that's where the formula for circumference comes from. You just multiply the damn d up and you get that, and then you diameter is twice the radius, so you get 2 pi r. So hopefully it sounds vaguely familiar. Okay. There is another situation where freaky ass shit. So I'm going to show you 2 ways this comes from. We all know what this looks like if you graph this. And I'm going to focus on the positive part, yes? Okay. So if I graph this, by the way, Maria, we're almost to a point where they can work on some stuff. I always feel so bad for you when I'm just droning on. Is that cool? You guys are kind of with me? It's got a, when x gets really close to 0, it goes to infinity, yes? It's got a vertical asymptote at 0, yes? And then when x gets really big, it goes to 0, yes? Here's what's really, really trippy. And when you get to calculus, you can ask your teacher to show you then also. I'm not going to show you calculus. I'm going to show you the idea. There is a certain number that, do you all agree that if I go from 1 to something, there's an area here? Now, it's a very funky shape, correct? It's not a standard geometrical shape that you have a thing you pull out. Yeah, if the area is pi r. No. No, I don't know what the shit that is. In calculus, one of the things you learn is how to get an area like that. You can calculate any area given a function that it lives under. Sounds intriguing. We're not going to do that. There is a number that if I stop at that number, the area under this function from 1 to it is exactly 1.
Weird.
And that number, that number is e. And we're actually gonna figure out what that number is in a minute, huh?
Damien was talking about this, sorry, keep going.
Oh yeah, okay.
You just
If you've done any situations where you have population growth, throw a couple of bunnies in a room, give them some food, and wait. E is used to model population growth. And you can see the growth rate in the formula itself. Okay, you guys know. So. The other place it comes from, I like to start with this one because to me this is the more interesting one. The other place, I'm not gonna, okay. Do you guys know how to calculate simple interest? Whenever I teach the simple interest formula, I just say I be pretty. That's the formula. Yes?
Okay.
I am pretty. So pretty. Okay. If I assume, okay, if I want to know how much money I've got at the end of whatever, I would take the amount that I put in plus that interest. All right, now I'm not going to make this into a business class. So I'm really sorry if you love business. I hate the shit out of it, but I'm not going to make it into business class. That is very basic. Take the amount you put in, add the amount you made over whatever time, and that's how much you got in there now. Is everybody with me? Okay, you guys really with me? Okay. Bless you. That's the amount that's in my account. Do you guys see how I can pull a P out like that? Factor a P out. Is that all right?
I'm sorry.
Go ahead.
Is it PR?
Yes. P is the principal, the amount you put in the
Yep.
bank. R is the interest rate.
Okay. And T's time? Or,
T is somehow top. No, T is time.
Oh.
Okay. So, let's see if I can do this semi-quickly. So, everybody, you should have some understanding of this. Yes? If you leave your money in the bank for a longer time at a higher rate, you're going to make more interest. And that's because of this formula. Yes? Now, there's a lot more to that. I'm not gonna teach that business. So let's say I put $1 in. Watch out. I put $1 into the bank. Yes? I have this account. You have no idea. This account has a 100% interest rate. Thank you very much. And all I did was put a damn dollar in it. I'm stupid, but we'll move on. If I really don't. there's something called compounding. And that's when they actually add the interest, right? So if I leave it in the account for a year, T is 1, I'm gonna make, and remember, this is the formula, T is 1, so I'm just gonna leave that out. I'm gonna make, so after 1 year, I'm gonna make $1 times 1 plus 1, 100% is 1, is that cool?
Yeah.
Bam, so I'm gonna make $2. Makes sense. If I have 100% interest applied for a full year, I'm gonna double. That's what 100% more means. If instead, is everybody with me so far? Okay. If they instead were to apply the interest halfway through the year, now I want this to really make sense. That means for the second half of the year, I'm letting that interest itself grow also. So doesn't it make sense I should end up with more than $2? So I put halfway through, I go, okay, how much interest is that so far? Actually added in right now. Now let it keep going. Yes? So, after, sorry, no, not quite. Not that good, sorry. So if I instead compound twice a year, halfway through, by the way, if I compound twice a year, I'm doing 50% each time, so I get 100% total. Okay. So I'm gonna have $1 times 1 plus 1/2, 50%. That's halfway through, that's 6 months in. Are you guys with me? Okay, I'm boring myself right now, I hate, but you know, it's all right. This is neat, We're gonna actually get the actual number that E is. Like you all know what pi is roughly. It's not like I'm making myself believe it, it's right. If I let it ride for the rest of the year, how much money do I have in my account right now after that first 6 months? They put the, huh? Yeah, I got $1.50 right there, right? So I start with $1.50, right? And then I apply 1 plus 1/2 again, yes? So let me write this even better. Is this just 1 plus 1/2 squared? Okay, let me stop for a minute. Is everybody with me? That is because that's how much I have now before the second 6 months happens, times 1 plus the rate, which is 50% because I cut it in half for the 2 time periods. Is everybody semi with me? This shit's not going to be on the test, by the way. Still pay attention, but don't like. So what if I did what if I did 3 times a year, every 4 months? What would happen? It would be 1 plus 1/3, yes? And then it'd be 1 plus 1/3 again, and then it'd be 1 plus 1/3 again for each series of 4 months. So it'd be 1 plus 1/3 cubed. You start to see a pattern. What if I did it 8 times a year? What would it be then? 1 plus 1/8 to the 8th. All right, so somebody who's got the calculator, let's see. If I do it once a year, I get $2. If I do it twice a year, what do I end up with?
$3.
No, what's 1 plus 1/2 times 1 plus 1/2? 1.5 times 1.5. No, times. 225. Right, multiplying, correct? What's 1 plus 1/3 to the 3rd power? All right, let's see. Hold on. If you need to borrow a calculator, I got them up here. Some of them even have battery, not that one. So like that, right? 1 plus 1/3 cubed, yes? Come here. 2.37, blah, blah, blah. So what if I do 1 plus 1/1,000 to the 1,000? Let's see if our calculator can handle that. So if I do it 1,000 times a year. 2.716 times blah, blah, blah. And then finally, let's do, let's see, 1 plus 1 over 1, 0, 0, 0, 0, 0, 0. I think this might be, let's see if the calculator can handle this. How many zeros you got there, Jeff? 1, 2, 3, 4, 5, I think it's 6, yes? Yes, there we go.
Didn't really change that much.
I know. At some point, you get diminishing returns. So you keep dividing the year up. So like I was doing it once a year, and then every 6 months, and then every 4 months, and then you're getting now like every day, every half day, every minute, every second, every millisecond, every femtosecond. What the shit is that, Jeff? I don't know. It's a very small piece of a second. You guys kind of. And then as you do it, do you see we are approaching a number? So, using the notation I showed you before, the limit as n goes to infinity of 1 plus 1 over n to the nth, we call that e. On the calculator, there is an e button. E. Notice it's above this ln that I accidentally wrote earlier. They must be related because they're right next to each other. So if I hit e to the first power, that's the number. And look how close we got to it. That is if I make this number go to infinity. I let it get as big as anybody can imagine, and then I double that, and then I double it again, right? Are you guys at all with me? So we gave pi a symbol. Pi is a number, just as a number, but it happened to be a number that had no pattern and it never ended. Dear God, number, give us a break. We gave it a symbol because it was freaky and we wanted to use it. E, same thing. It's freaky. It's neat. It's got a couple places it comes from. We gave it a letter and then we noticed all these uses for it. Thank the gods we gave it a letter so that we can write shit quickly. Instead of 3.7. No. E. Leave me alone. You guys go with me? Okay. So, I want to incorporate what we. Oh, sorry. Who knows? Here? Oh, there you go. I knew I had more paper somewhere. Did it make sense what I wrote? Okay. So, let me ask you this, just to make sure we're all on the same page. If f of x is 2 to the x, what's f inverse of x? You can do it. Yes. Go ahead.
Log base 2x.
Log base 2 of x. You all know what logs ask you, yes? We talked about that. We went over that. We know what logs mean. We actually figured out what a log looked like before I told you the function, because we actually drew the inverse of an exponential. What's up?
Log base 2 of x is asking what power do I raise?
Yes. So what is the output for a log? The power 2 gets, yes? Let me say it again. The output to log base 2 of something is the power 2 gets. That's the output of a log. What's the input of an exponential? Where's it go? Ah! Input becomes the output, right? Student becomes the master. No. You guys that all with me? These are inverses. We drew this guy's graph before I even gave it a name. How did we draw it? We found the inverse of an exponential. So of course they're inverses of each other. In fact, what is log base 2 of 2 to the 5th? 5. These killed each other because they're inverses. Or 2 needs a 5 on it to come to the 5th, but really they kill each other because they're inverses. Poorly, they're like antimatter. Put them close together, they annihilate. Watch out for the energy coming off, could be x-rays. Okay. Just to make sure everybody understands, if I have log base pi of x, what is the inverse? What we got? You can do it. Log base 2 of x, what's the inverse? 2 to the x. Log base pi of x, what's the inverse? Pi 2 to the x. Right? Don't freak out. I put pi there. Who gives a shit? It's just a number, right? Okay. Now, here's the last thing before I shut up finally and let Maria get up and do some stuff with me. What is the inverse of e to the x? Now this is, now listen to me. I want you to listen to me very carefully. This is gonna sound weird. This is gonna hurt me. This is gonna hurt me to write this. A little bit, it hurts me a little bit. Because we don't write that. We are weird people. Look at what we did. We call the function log. We are weird as shit.
Don't those cancel each other out?
No, you're thinking about something else, we'll get there. This, we use this symbol. And then that leads to dumbass jokes about natural log cabins and shit. You can look it up. Look up the dumb math joke about natural log cabins. Okay. Yes?
Just to clarify, you're saying ln is loggy?
ln is logging. One more thing before I forget. What does this mean again?
Half power.
Square root. I'm sorry, I should have said how do you read this? Cube root. So what's really here that we just don't write?
Two.
There's a 2 there. Why don't we write it? Because it's the most commonly used root. So we just said, we'll just all understand. We mean it's a 2. What does this mean? Read it, I'm sorry. Log base 3 of x, right? So what does this mean?
Log.
No. Base 1 would be weird because 1 to every power is 1. So log base 1 doesn't exist.
ln of x.
No. ln of x is log base e is ln of x. The most commonly used base, believe it or not, is 10. Richter scale is based on base 10 logarithms. So when you see a log with no base, you know it's base 10. For some reason. I don't know why. Okay, so you guys with me? ln means log base. Log means log base 10. All of this shit you have to keep in your brain because this stuff is easier because we know what it means. We know what it's telling us. So let me finally shut up and let you guys try this out. All right, guys, are we ready to take a look? Say goodbye to Balloon Man. Bye, everybody. Poor little guy.
Maybe not.
So guys, I know I didn't talk about this today. We've talked about these two ideas before. They are very much linked together. This is slightly easier than that because as Aubrey has given me one of my favorite phrases moving forward, instead of snail like one of my colleagues, this is the washing machine. Yes. 3 to the 10th equals y, right? You did not have to throw this in your calculator. I just want it in exponential form, and it's exactly what it is, exponential form. Do you notice how the input became the output? The output became the input, yes? So you can do the same thing here. What's the base? So I know I have log base 7. The output is 5.6, that becomes the input. The input was w, that becomes the output, and if I want to check myself, before I wreck myself, 7 to the w equals 5.6. I like it. You got it? All right, good luck tonight.
Thanks.
Enjoy tomorrow.
I will try.
Please shut up.
Goodbye. Bye, Maria.
She's
Have a good time.
Good luck with your move. Treat yourself to pizza after. I'm lactose intolerant.
Oh.
Cheese pizza.
Yeah, whatever the lactose intolerant sad version.
the best dairy-free pizza I ever had was in Sonoma, California, believe it or not. Sonoma, California.
Where's that?
Middle of nowhere. We were visiting all the parks and we were driving back down and we stopped in Sonoma, decent little place, hot as shit. Got some pizza, the water was terrible, and I'm like, that's not a good sign. The water was terrible. And I poured it in the plant, I'm like, in a week this will be dead. And they brought the pizza and I'm like, it was just good pizza, you know what I mean?
Yeah.
It wasn't even like good for dairy free. It was just good. And it was gluten free.
Wow.
That's
I mean,
impressive.
yes.
Wait,
That's
this was
rare.
dairy
Because
and-
Jeff was dating somebody who couldn't do either one.
Was it, wait,
And I was the guy who always had to find where we were gonna eat, and that
So,
wasn't stressful.
was it dairy free or lactose free?
It was dairy free. Is that different from lactose free?
Yes.
No, the cheese was definitely not dairy.
It was vegan cheese.
Vegan cheese.
Incredible.
I know. And it was gluten free freaking crust.
It's made of like, it's often made of what, like coconut, soy with oils and
Dude.
stuff like that.
Yeah.
Also, if
Yeah,
you
I think
if you don't know, there's a place called Kula. They make damn good ice, just good ice cream, just good ice cream, and they're in what is the name? Sorrento Valley, I think is the name of the place. They're up in that area. Yeah. Okay. Enough. Sorry.
Is it dairy free?
That's the whole idea. It's
vegan
dairy
ice
free. No, I don't.
Is it vegan?
It's dairy free. I don't know.
That sounds nice.
All right.
Just dairy free.
So
That sounds-
this one, easiest one, yes.
Mm.
4 to what power is 1? That's insane. This one, eventually, you're going to start to realize this is easy as shit. Because that is log base E. Log base E, whenever it comes across E, kills it. Just like if a cube root, they kill each other. So, die, the answer is pi. Another way to look at this, I can't believe we're going to write this again.
Third time today.
These kill each other and the answer is pi. Okay. This one I can look at the same way, but I mean, how many pies does it take to make pie? Sounds like a weird ass joke. This one is the same as that. What's the base on this log? Understood to be 10. Same way that the number in the square root is understood to be 2. These kill each other, the answer is 4. Kick ass. This one, if you remember, 2 ways to look at this. Log base 2 of 16 is 4, therefore log base 16 of 2 is 1/4. If it takes 4 2's to multiply by 16, it takes 1/4 of 16 to go back to 2. Or you think about what root do I have to take of 16, but not a lot of us have 4th roots memorized. Understandably, yes? Another way to think of it is, how many parts do I have to break 16 up into until I get a 2? So if you break 16 up into 4 parts, 2 times 2 times, are you with me? How many of those parts do I take to make 2? 1. So let me trip you out here. You ready? You're all like, it's all you ever do, man. What's log base 16 of 8? Here's the easy way to do this. No, 16 to 1/2 is 4. You with me?
Yeah.
Okay. Break 16 up. How do I make 8? How many parts do I need? Out of how many total? 3/4 done. Yay. Okay. Whatever.
I feel like one of those kids in their first math class where you draw the circles, and the plus sign, and then the circles.
Yes. It ends up looking like a football player. Then you come around here. I put these kind of problems together on purpose. If I know what power makes it 2, what's the only thing I have to also do for this guy? Flip it. So I know this makes it 2. What do I also do to make it flip? Negative. So if I know log base 3 of 9 is 2, what's log base 3 of 1/9? Negative 2. So if I already know the answer to make it something, how do I make it become 1 over that thing? Just put a freaking negative sign on it. Yes, that's it. Don't look at it like a brand new problem. I put those together for a reason. And then this guy, if you just rewrite it, what's this? 11 to the what power? Okay. And then what happens to the log 11 thing? Kill each other 1/5. All right, so I apologize for all the death that happens on my worksheets. These, I almost don't even care. What'd you guys get for this one? 10 point something? 10 point blah blah blah. What'd you get for the natural log of 111?
4 points.
Blah blah, okay. What'd you get for, I should be more, huh?
Negative 0.38.
And why does it make sense? Because I'm trying to take 10 and cut it down to 0.4, so yeah. Okay, and then finally this guy. And all I have to do is take the who to what and do what to it. Inside has to be bigger than 0 to keep this nice and real. And then I just solve. So I think most of you guys might have done this, maybe. So what happens?
Flip the sign.
Flip the sign. Let me show you this a different way. What if I added the 2x and then divided by 2? But isn't that a little weird? Don't we normally have the x on the other side? This says 3/2 greater than x, correct? Read it the other way. It says what? X. There you go. So I flipped the sign for the reason I already showed you, but I also flipped the sign because if I would have done, oh shit, I'm sorry, my little balloon thing is still. I also flipped the sign because if I would have taken it the other way, it would have ended, the x would have ended up on the other side of the sign. Do you guys see that? So in a sense, it's almost a shortcut, but not really because it actually, I flipped the sign for a valid reason on its own. Okay, maybe. All right, the only other thing I wanted to do, let's see how much of I could do with it. Let me make sure I didn't forget anybody. No, good, all right. I want to talk a little bit about just general properties of logs. Now, I am gonna show you the complete picture of the whatever that's it. Properties of log, sure. Properties of logs. I'm gonna show you one of them completely. And then I'm gonna try to show you a shortcut to remember how it works. Remind me what logs are. What are logs? More practically, what are logs? What is the answer to a log? It's always a exponent. The answer to a log is always a power. So, I want to investigate what happens when I have something like this. When I have log based something of something times something, right? When I have the log of a product. Just remind me. And by the way, all right, you see. How do I want to say this? The base is b, yes? So these both have a base of b. Do you agree with me? When I multiply two things that have the same base, what do I do with the powers? What do I do when I have multiply two things with the same base? What do I do with the powers? Add them, yes? So this better come out to be some kind of addition because I told you the properties of logs are the same thing as the properties of powers because logs are powers. Okay, so what I'm going to do to investigate this, I'm going to call log base b of n, I'm going to call it x. Log base b of n, I'm going to call it y. Because I don't know what either one of those are, so I'm just going to call it the standard algebra shit, yes? I guess semi with me. This is going to be a little technical. Try not to tune out. I'm not going to make you do this yourself, but I want to show you the grounding for why this property works. Okay. Doesn't this mean right here, that how can I rewrite this in exponential form? B to the x equals m, and this says? Good. So what is m times n? Yeah, b to the x times b to the y. So what is it? Keep going. B to the
X plus B plus Y.
right, because you add powers when you multiply like bases, correct? Okay, I like it. Trip me out for a minute. Like nobody ever looks that way for that monitor. So you were looking that way. I'm like, shit. He's really just like. I don't want to listen to you. I want to make sure you know.
That monitor's like so clear.
I know. Yeah, this is a little fuzzy because it's it's got a couple things going against it. So watch this, guys. Wasn't I wanting to investigate this? Right? So you're like, it's about time to get back to that. So if I take log base b of both sides, I recover what I wanted to know, yes? I'm going to take log base b of this side. But we already know how this works, don't we?
Yeah.
What do those do to each other? Okay. So then log base b of mn is x plus y. Okay, let me stop for a minute. Now, there ain't no damn way you would necessarily know to do any of this shit. Are you with me? Right? In fact, right when I started doing this, I'm like, holy shit, I should have done this before class. I hope I remember how to put this together. Apparently I did, thank the gods. So it's not like a natural thing to do. This is nowhere near natural, but I recovered the thing. What was x? Remind me what x was. What did we define x to be from the very beginning?
Log base b of
Yes. So log base b of mn equals log base b of m plus, and what was y?
log base b of n.
Log base b of n. So what do I do with the powers when I multiply two things with like bases? I add them. That's all that damn thing says. The log of a product is the sum of the logs. I rub you guys. Let's try a concrete example very quickly. If I want to do, I'm going to do an example. You could do a different way, and I don't care. We're going to do it that way, and you're going to show we get the same answer. What if I had log of 10 squared, no, Jeff, times 10 cubed?
We just,
The property we just did, pretend like I forgot, you could combine those. How can I break this up using the property we just did?
log base 10
Log of 10 squared
plus
plus,
log of 10 cubed to
what's log of 10 squared?
2.
2. What's log of 10 cubed?
3.
3. Now, if I was smart, I would have done what from the beginning?
You would have combined them.
And what's this? And of course, it's the same answer I got that way, right? So that's the reason this works, is because the log just cares about what the power is going to be. So if I'm multiplying two things with the same base, the base on the log is the same for both of these pieces. I just add the two powers together. That's what we do. That's the property we're using. So how is this useful, dear God, Jeff? That was bullshit, Jeff. On one level, you should say, that's bullshit. Why would I just do this? Why would I ever do your stupid thing, Jeff? I'm just going to do that. Here's why. You ready? Can anyone tell me what log base 12 of 3 is? Tell me. Without using a calculator, just tell me what's log base 12 of 3? You have no idea. Let me just stop you. 12 to the 1/4 power is not 3. The 4th root of 12 is not 3. You guys with me? That was a little mean. I don't care. None of us. I don't know what that shit is either. I could barely even give you a good estimate. You with me? Okay. What's log base 12 of 4? I still don't know. But what's the sum of those two things that we have no idea what they are? They probably are funky ass decimals. How do I add them?
Log of 12, 7.
If I'm adding two logs, I can go the other way, yes? I can put them back together. So that would be log base 12 of what? No. 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 What's the property say? If I have the sum of two logs, I can write this log of the product. 12. What's log base 12 of 12? 1. Okay. So, funky ass decimal. Do you all agree with me? Whatever the shit this number is, it's a funky ass decimal. Whatever the shit this is, it's an equally funky ass decimal. But I know together they had to be 1. I don't have to know what either one is because I can do this and I just know it's 1. That's useful. Okay. Sorry. This property by itself is not always useful. This property leads to the single most useful property logs that you're gonna use a ton of. Since I said something else, let's talk about it real quick, and then we'll head out. I'm giving you tomorrow off, so what if you did, Jeff? What if I had log base b of m times m times m? How can I use the property we just discussed? What do I do when I multiply things with like bases? Add the power. So add the power of this one plus the power of this one plus the power of this one. Yes? You with me? So one thing to realize is this product can be as long as it wants to be, and I can just break it up. You with me? Now, what do I have? What do I have here? How do you do this? Are they like terms?
Yes.
How many of them are?
3.
So there's 3 of these. Coming back here. That's a dumb way to write that. How do you write that? M to the third. That power just comes down. What do you do with the powers when you raise something with the power to a power? This came up earlier. Like x squared cubed. What do you do with the powers? What do you do x squared cubed?
Move it to the front.
No, there's no log here. What do you do with the powers when you raise something with a power to a power? Multiply. You multiply the powers. What's a log?
A power,
And what's 3?
a power.
You multiply the powers. Every property of logarithms is a property of powers, because a log is a freaking power. Yes? This is the most useful property, and I'll show you why. If I had to solve this equation, you could estimate it. Could somebody give me an estimate for the answer?
2 point.
Yes, 2 point. That's all I need here. Yes. 3 squared is 9, so 3 to the little more than 2 is a little more than 9. Yes. How do I solve that exactly? What is the major problem here? Like real quick. This is a problem. This is a problem right here. I got a stupid 3 messing with my x. Shit. But how do we solve for x? We multiply by 3. But look here. The main problem here is, where is my x? It's in the freaking power. I can't, what the shit? If it was in the bottom, I could multiply it up. If it was inside of its cube root, I can cube it. This is in the power. But now what can I do? I can take a log of both sides. The log we normally use, you could use any log you want to. And math people use the natural log because there's one less letter to write. ln. Real quick. I need you to really get this. How would I solve x cubed equals 8? What would you do? Cube root each side, right? Take the cube root of each side, correct? Okay. How do I do this? The first step is take the natural log of each side. Now, both of these things are trying to do the same thing. They're trying to free the x up. Now, some of you guys might look at this and go, you made that problem worse, Jeff. Thank you so much. You got natural logs in my equation. Well, what can this do now? What property did we just discover? What can I do with the power here? It can do what? It can come down. So I freed the x. How do I solve for x? Can you read this for me? What's this say? Don't say x ln 3. What's the operation here? X times, and how do I get x by itself? Divide by the shit I don't want. I don't want ln 3. I don't want it. Bam, there's the exact answer. And then you can put that in a calculator and get a decimal answer, who cares? And let's do it. You guys, we said it was 2 point something, right? Anas is like, I would have said more if you would have let me, man. Not that much up. It's almost dead. Poor little guy. So ln of 11 divided by Jeff. ln of 3. 2.18, blah, blah, blah. And if I do 3 to the that, I get 11. That's amazing. I know. So that is the most immediate usefulness of log properties. And without the first property, there ain't no way this property would exist. This is the one you're going to use the most. Let's do one more property. I'm letting you guys have tomorrow off. I have to do one more property. Real quick, remind me. How do I do the log of a product? How can I rewrite it?
Log bn plus log bn.
Okay. So what would your guess be for the log of a quotient?
Minus?
Yeah. Oh, that's all it is. So I could go through a whole thing. I'm not going to. Let me see if you guys are cool with this. Do you see how I got there?
Yeah.
Isn't that a product now? You with me so far? Yes? I can bring the n up. It's to a negative power now because it wants to be below. So when I brought it up, it got all angry. So now it's negative. It's a product, so I can break it up. And where can that negative 1 go? I'll tell you where you can put it. Where can that negative 1 go? Out front. So then it becomes log base b of n minus log base b of n. So we say, screw this shit, Jeff, let's just make that a thing. So the log of a product is the sum of the logs. The log of a quotient is the difference of the logs. I did not make division become subtraction. Nowhere up there did I do that. It's just a quirky property of logs that this is true. Okay. That's it. That's it. Okay. So next time I've got a little handout about these rules. We'll do it, and then a whole lot. Oh, what the hell? Is this the same thing, Jeff? That's pretty funny. I'll have that for you next Monday, because what's happening tomorrow, in case somebody came in after we said this.
Nothing. Got the day off.
This class will not meet. You'll have tomorrow off. We have a nice, somebody pointed out, and I'm like, I could use a break. You guys could use a break. Let's take a break. So tomorrow, don't come to class.
Teacher of the Year award.
I gotta ask, sure. What's the best thing I could do for you guys is to just let you go away from me. Let us not listen to you anymore. Okay.